Okay, so that was the clip that we were going to be analyzing, and we were trying to find if the jump distance between the two tracks is possible.
Okay, so let's draw a free body diagram for the cart. Going downward, we have gravity, and acting upward, we have drag force. And then going to the left is also drag force, which we'll label as minus BV squared. Okay, and we only care about the horizontal direction because we just want to see if it can clear this horizontal distance. We have in the horizontal direction that the net force is equal to minus BV squared. And we can set that equal to F net, which by Newton's second law, we know is equal to mass times acceleration. And now we know that by definition, A is equal to the derivative of velocity with respect to time. So we can rewrite this equation as minus BV squared is equal to M times dV dt. And we want to solve for the equation of velocity so that we can find an equation for position by integrating. So let's multiply both sides by dt and divide by minus bv squared on both sides to get that we have dt is equal to m times dv over minus bv squared. Okay, and now we can integrate both sides to find an equation for velocity. We can do the integral of dt is equal to, we can factor out minus m over b because that we know is a constant value. So that's equal to minus m over b times the integral of 1 over v squared dv. Okay, now let's just go up here to finish up that integral. So the integral of dt is just t, and then we have that is equal to minus m over b, and then the integral of 1 over v squared is just minus 1 over v. So now, multiplying those two together, we have that t is simply equal to m over bv, and then to find velocity, we have that v, we can divide by t on both sides and multiply by v on both sides to get that v is equal to m over bt.
So now that we have an equation for velocity, which is v is equal to m over bt, we can use this to find the equation for the distance traveled. Since velocity is the derivative of the change in position, we can just do dx over dt is equal to m over bt. And if we multiply both sides by dt, we can isolate dx. And then if you want to isolate x, we can just find the integral of both sides. So if we find the integral of dx is equal to the integral of m over b t times dt. Let's multiply here. Right. And now the integral of dx is going to be x, and the integral of this side is going to be m over b. Since they're constants, they just come out of the integral, and multiply that by the ln of t. So to find the height of the minecart, we'll just use Harrison Ford's height as the scale, and we find that the height of the minecart is around half of Harrison Ford's size. Using the same scale, we see that the minecart's width is around 5/12 of Harrison Ford's size, and its length is around 4/12 of Harrison Ford's size. Using the width of the minecart, we can see that it takes 4 minecarts for the whole jump to be taken, which means that the horizontal distance traveled is around 2.46 meters. And using everything we have found, we know that the area is going to be the length times the height, since that's going to be the horizontal area of the cart, which is 0.5 centimeters squared. And we know that the constant for drag is going to be 2.1 for a rectangular box. So we plug that in the drag equation below, in the drag coefficient equation below, to get 0.718 for the drag coefficient. And the mass of the hole is going to be the mass of the minecart plus the mass of the 3 people inside of it, which we get as 192 kilograms. And the time it takes is going to be 154 seconds, which is found by seeing how many frames it took and dividing that by 24. And the movie's traveled distance is 2.46 meters, as we established before.
Plugging in the values that we found for m, b, and t into the position equation that we found earlier, we found that the minecart should theoretically travel 115 meters in the time shown in the movie. Of course, that means that it is possible for the minecart to clear the jump of 2.46 meters. However, we must acknowledge that this distance of 115 meters is far larger than we expected the minecart to be able to travel, and this could be due to some error we made in the experimental part of our calculation.